Welcome to AI Impact and Strategy. In this video, we're going to have the third segment of our discussion with Yves Caseau of Michelin. This video, though, is a little bit different than the prior two. In the prior two, we focused on artificial intelligence. In this part of our discussion, we're focusing on system dynamics models, which Yves has been working on for many, many years, and which he has recently begun publishing about. The underlying focus here is therefore on complexity and complexity management rather than specifically on AI, although we'll get to a quick mention of AI toward the end of the video. System dynamics is an approach to the modeling of complexity, which was pioneered by Jay Forrester of MIT in the 1960s and 70s. The technique of system dynamics identifies interrelationships between critical variables and tries to model how those variables interrelate and how those interrelations result in the behavior of the large and complex systems which we observe and which our entire world is composed of. Yves spent many years modeling the complexities of the cell phone marketplace for Bouygues Telecom, where he worked for a long time. And then in 2019, he returned to system dynamics modeling to look at climate models to model the energy transition as we shift from a fossil fuel era to a sustainable fuel era globally. So we begin with Yves telling the story of his modeling career, first at Bouygues Telecom and more recently with his CCM model, his climate and energy modeling approach. Can we take a few minutes and you can talk about your CCM?
Yes, let's do that. Let's talk about CCM.
So tell us the story.
The story is interesting because I've spent 15 years working on system dynamics model of competition, different kind of markets. As you know, I was working for Bouygues Telecom at that time, and I worked a lot on what will happen if we have to buy a 3G license and a 4G license. What will happen if Free, so a small, very aggressive, very disruptive player, when we heard they were coming, it was interesting. So, okay, let's do a model to see if they come and they slash the price, what would happen. So I worked on different ways of looking at this type of problems and playing with game theory and trying to see different players or the different competitors would eventually find a balance, an equilibrium, or whether there would be a fight until one of the players was kicked out of the market. And it has turned out to be very interesting. That is, in retrospect, 15 years later, you look at all the trajectories, everything that the model said, what actually happened. And sure, it's not a crystal ball, but it pointed out in a couple of interesting directions. So it was time well spent. Then I had a short period where I was a member of the scientific council of EDF, the large French utility company. And I was also a member of the scientific council for Bouygues. And they were on very different view of what the world of energy would look like in the future. So I started to try also to model this very top-down, network-centric view of EDF. Versus the Bouygues was promoting, creating smaller factories and smaller power plants and saying with the smart grid we will evolve towards a very distributed model. So I wanted to understand and I played with my model. It was around 2009. So the ancestor of CCM started at that moment, trying to see how I could model the energy transition. I worked with a number of members of the Academy of Engineering, together with my father, who has worked for EDF all his career. Then he passed away and I got distracted and I took my code and my equations and my numbers, frozen. In 2018, Nordhaus got his Nobel Prize. Curious because he talks about model and climate. And so I started reading his papers. I said, actually, this is cool. Maybe I should resume. So also it was very interesting because in the 10 years between the moment I stopped and the moment where I resumed, shale oil has been found. All the hypotheses that I had in 2008 were no longer true. But at the same time, if you factored in the new hypothesis, the old model was actually doing a good job. Something I should say earlier is that when I started to work on the competition in the mobile phone companies, I found that there were a lot of players doing the same. We worked with McKinsey, they had their own model. I worked the Bouygues Telecom strategy. And although they were all very similar, there was some common structure. So we were building the models and torturing the model. And sure, we were producing different stories, but there was some underground narrative that was there that makes the exercise interesting. It's a little bit what you say in your book. You develop your own, you try, you find that some of your intuitions are totally wrong because the physics doesn't work. You prune your model, and at the end, you find that although the future is very uncertain and it's just a tool to create multiple scenarios, there are some things that
So do you think that would relate to what I talk about in terms of the patterns of change in the deeper structures as opposed
yes,
to
it's the deeper structure. It's exactly the deeper structure.
Yeah.
And I came back to I would say the drawing board in 2019. By that time, AIM integrated assessment model had become popular. There were lots of them. They are used by the IPCC. There are still model of the system dynamics type, which is my school of thoughts in the spirit of Forrester, Sanger, and all those great persons, great guys. And I looked at everything that was there. Does this make sense? And I figured that there were a number of things that were missing from most of the models. They were a little obscure. They were very dense. Lots of the deep beliefs, they were hidden in the equations. You could not play with them. Okay, so let's build a model where my intuition about the peak oil, where clearly what I believe today is different from what I believed 15 years ago. I could see very quickly that the speed at which we can deploy solar and wind is a very deep unknown. Not too much the speed at which we can manufacture, although manufacturing wind, you need so much alloy and steel and so on that it's photovoltaic. Chinese have made so much progress but once you have the panel, shipping it, deploying, install it, it's a long journey.
Connecting it to the grid and creating the storage.
Exactly. So it became frustrating in the positive sense of reading all those papers about net zero scenarios, especially the one that are promoted by COP, the one from IRENA. So the more I read, the more I said, okay, you have a large family of models that are bespoke models. They have been bought by an agency that says, please make me a model that says this. So the scientists are very pleased to do as they're asked, but it's almost shocking from an outside view. That is, the math is beautiful and the models are okay, except that they should have a big disclaimer saying, since we were asked to produce a net zero trajectory, we decided that we could have 30 petawatt of solar within the next 10 years. The fact that it is 50 times more than we've ever done, we will not tell you. So I'm unhappy with that. I'm trying to create, as a side benefit of CCM, what I call the Energy Matter Manifesto. I want to produce a one page saying, whenever you read the model from somebody else, including from Yves Caseau, those are the 5 questions you should ask, and you should have those answers. I'm discussing with my colleagues at the academy, and I say it's not the longer the list, the better. It's the opposite. We should focus on a small number of key questions for which, and don't try to do everything. Just put a nail saying you should not be allowed to produce your opinion about the future without telling us, the reader, what you believe is feasible in terms of the speed at which we are or decreasing the use of energy per each dollar of GDP. That's very fascinating. I started working with current dollar, and at some point, a colleague, a university professor, said, whenever you have the time, switch to constant, because it's a little bit of a mess. It's not an exact science, but your curves are going to move much more slowly. They are better behaved. It will give you a better picture. And it's very true. If you took the GDP in constant US dollar and you measure how much energy, sure, it's going down, but slowly, very slowly. The world is not going to save us by magic. It's very clear we do need energy. So that's how CM was rekindled, saying, okay, I want to do a model And as soon as I made some progress, I said, it's very clear. You have to remember that I spend my life in planes. My biggest team is in India. I go a lot to China because I have team in China, and I go a lot in South Carolina, South Carolina. And I really have factories everywhere in the world, so I do travel a lot. So the more you travel, the more you find that European-centric vision is very self-centered and not very representative of the world. Clearly, the rest of the world is sort of much more excited about growing and improving their standard of living and say, okay, so I figured I need a model where I can play with that. And then I don't know what exactly what you say in your book. I don't know what the future is, but I want to do. I really love the pages about geopolitics and democracy versus let's see what I can get. And I find, since you're a big fan of anti-fragile and so am I find that doing a model like this, it's an anti-fragile activity
Yeah,
because
agreed.
you do a model, you talk with someone who says, "Oh, I really like this and this, but this I disagree with you," and then you say, "Oh, you change a little bit," and you come back, and that is very pleasant because the more you get positive criticism, the more you evolve, and that's the beauty, by the way, of system dynamics as a modeling tool. That you can welcome. You say you're missing this loop. Say yeah. So sometimes you say I will not take this loop into account because, for instance, a good friend of mine is the specialist in France of the fact that you need more and more energy to produce iron. Okay, so he's very excited about that. And but I told him, I after reading your papers, I did a web search, and now I have large pile of papers. Half of them is saying we're making so much progress, it's not an issue. The other half is saying we are doomed, we don't have enough iron. So I make this variable. I'm not buying his fear, but the discussion was really interesting.
What systems dynamics modeling tool are you using?
This is where I'm using my own toolbox. So I have a high-level programming language called Claire, which I developed long time ago. So it's sort of the structure is very simple. You have objects and we say all the mathematical rules, but the dependencies, I write code. So I write equations first because I want to publish paper, but at the end I write code. It's a high-level modeling language. It's a good language for this. The bad news is it's an obscure language. It has a small, it's called productivity. So right now I'm generating JavaScript, and I will generate Python very soon to say to put it on the website. Say if you want to play, you're welcome to play. You don't have to use my strange modeling language, but it's a good tool. First because I've been using it for decades, so I know it. It's a Lisp-inspired language from the old days, but it has a Go compiler, so it generates code that is very fast. So you can use it two ways: to play and explore, use it as you were using Python. I mean, frankly, if I only wanted to explore, I would probably have switched to Python. But I don't want only to explore. Once I have a model, I want to shake the model. I want to apply game theory. I want to randomize. So I need then from that model to generate something which is very fast.
You think you could train an AI agent to use the model and then run hundreds of simulations in very fast?
Yes, that could be done. That could be done. Extra, I will put my own agents that are, I would say, good old-fashioned AI agents that are simply, but it's very. As soon as I'm done with that, I want to play with the toolbox. There are so many other techniques today. It's rule-based AI.
I've taken an awful lot of your time. I really appreciate it. It's been fascinating to listen to everything you wanted to share with me. Thank you so much.
No, you're welcome. I really enjoyed that conversation. And as I said, I told you so, but I really enjoyed your book. I bought a copy for one of my boss at Michelin, and I bought it. But I think 6 months from now, I will call you and I will let you know how I want to incorporate your way of thinking into the model. Because
okay, so we be in touch, okay?
Let's be in touch. Absolutely. Okay. And
thank you very much. Well, you undoubtedly noticed that Yves mentioned anti-fragile toward the end of that conversation. Anti-fragile is the name of a book written by Nassim Nicholas Taleb. And the concept of anti-fragility is pretty simple. Some systems become weakened when they're stressed, but other systems become stronger. Anti-fragile systems are the ones that benefit from stress, that benefit from complexity. And that describes very well why we build and use and continue to work on refining these models, because it helps us to understand the behavior of complex systems and to anticipate their future behaviors. And in this era of accelerating change, understanding the future is, well, it's a critically important thing for us to be doing. We'll be continuing to follow Yves and his work in CCEM, as well as his work in Michelin. As you've seen, if you watched all three videos, Yves is clearly a pioneer in his thinking and is clearly achieving great things for Michelin and perhaps with CCEM for all of us. I'm grateful to Yves for spending so much time to help us understand his work, and I hope you found these videos as interesting as I did in my discussions with Yves. There are a couple of references that you may be interested in. Yves has a website for his CCEM work. He's also published recently a scientific paper on CCEM. And in the summer of 2024, Yves gave a lecture on CCEM at AXA, the insurance company. And the video presentation of that lecture is also available online. Now, we think system dynamics is a very important tool, and we'll be continuing to explore the intersection between AI and system dynamics in future videos, including one very, very interesting video that I recently recorded with Dr. Stephen Dam, who is indeed using AI to model complex systems. Look for that video to be posted very shortly. Thanks for watching, and we'll see you soon.